If all the elements above or below the principal diagonal are zeros, then the value of a determinant is equal to the product of the principal diagonal elements. If all the elements above or below the principal diagonal are zeros, then the value of a determinant is equal to the product of the principal diagonal elements. Let delta is equal to a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3, b1, b2, b3, c1, c2, c3. If this reduces to 0, straight away you can multiply all the elements below the principal diagonal are 0, therefore this is equal to product of principal diagonal element. Hello dear students, welcome to this session. I am M.J. Niranjan, the Faculty of Mathematics, Vidhyaashram PU College. Now in the previous classes, we have discussed regarding the properties of determinant. In this session, I am going to discuss regarding remaining properties. So there are 4 more properties which has to be discussed today. Now let us discuss the first property, the property number 4. What is the property number 4? If each element of a row or column of a determinant is multiplied by a constant k, then its value is also multiplied by the constant k. That means if any row or column, if all the elements in any row or column is multiplied by a constant k, this constant k, then its value is also multiplied by k. That means here, suppose let us consider this. Let us consider that delta is equal to a1, a2, a3, b1, b2, b3, c1, c2, c3. Suppose if you want to multiply by k in first row. Suppose if I want to multiply by a constant k in first row, let us multiply by k. Then what you will get here? Delta 1 is equal to k into, this is same, a1, a2, a3, b1, b2, b3, c1, c2, c3. That means here, so just evaluate this, find out the value of this determinant and multiply by k, or just multiply any row, first row or first column, second row or second column, third row or third column by a constant k and evaluate it, you will get the same answer. So that means if each element of any row or column of a determinant is multiplied by a k, then the whole determinant, then its value is also multiplied by k. That means you can evaluate this and multiply by k, or just multiply by k for any row or column and evaluate it. So what is to prove is, now let us multiply this. If I multiply, what I am going to get? K into a1, k into a2, k into a3, and second row are is same b1, b2, b3, c1, c2, c3 as it is. Now let us first simplify this. Now what is to prove is, so the value of delta 1 is equal to k into, the value of delta 1 is equal to k into delta. This is to be proved. Now let us simplify this with respect to first row, plus, minus and plus. Now delta 1 is equal to, simplify this, k into a1, delete the row and column containing this is gone, b1, b2, c2 minus c2, b3, b2, c3 minus c2, b3, minus second element is k into a2, delete the row and column containing k into a2, what you will get? b1, c3 minus c1, b3, right? And the last plus k into a3, delete the row and column containing this, you will get b1, b2, c1, c2, this can be written as b1, c2 minus c1 into b2. Simplify this. This is equal to k into a1, b2, c3, or just keep k out, k into a1, b2, c3 minus a1, b3 and c2, minus, you can keep k out, this is A2 B1 C3 minus A2 B3 C1 plus K out, you can write A3 B1 C2 minus A3 C1 into B2. Now, this is equal to K into, if you observe carefully, this A1 B2 C3, see, take this element A1 B2 C3 minus A1 into C2 B3, this is nothing but the expansion of the determinant. So, if you multiply any row or any column by a constant K, evaluate it, otherwise, but just evaluate and multiply by that constant K, you will get the same answer. That means each element or row, any element, that is each element of a row or column of a determinant is multiplied by a constant K, or the whole determinant is, the value of the whole determinant is multiplied by that constant K. So therefore, what you say that delta 1 is also equal to K into delta 2. Now let us take a small example on this. Or on the other hand, you can also remove the common factor. You can remove a constant K from any row or any column. Now let us take an example. So here let us take an example. For example, I will take an example. Let us consider let A is equal to determinant of A is equal to, let me take a 2, 4, minus 2, 3, 2, 1 and 0, 1 and 2. Now multiply this, just find out the value of this determinant. So the value of this determinant is plus, minus and plus 2 into, it is gone 2 to the 4, minus 1, minus 4 into, delete the row and column containing this, 3 to the 6, minus 0, plus into minus, it is minus 2 into, this is gone 3 ones are 3, minus 0. So this is 2 into 3, minus 4 into 6, minus 2 into 3, 6 fours are 24, minus 6. So minus 6 plus 6 gets cancelled, you will get the simplified answer as minus 24. Now suppose, let us multiply by 2, multiply by a constant 2 for first row. Suppose if we want to multiply, call it as the A1. So multiply by a constant. So multiply by a constant. So each and every element is to be multiplied by 2. Multiply by 2. 2 into 2 is 4. 2 4s are 8. 2 1s are 2 2s are 4. Second row same, 3, 2, 1, 0, 1 and 2. Simplify this, that is plus, minus and plus. This must be equal to, what is what we are going to multiply here? 2. So this must be equal to, so that is 2 times the matrix, that is nothing but 2 times the matrix determinant A, that is 2 into, the value of determinant is minus 24. So you are going to get minus 48 as the simplified answer. Let me check. So that is 4 into 2 2s are 4, minus 1, minus 8 into, this is gone, 3 2s are 6, 3 2s are 6, minus 0, minus into plus, it is minus 4 into, 3 1s are 3, minus 0, this is 4 into 3, 8 into 6, minus 4 into 3, that is equal to 4 3s are 12, minus 8 6 are 48, plus into minus, it is minus, this is minus 12, minus 12 plus 12 gets cancelled, you will get minus 48, minus 48. So that means multiply by 2 for first row and evaluate, you will get the answer, or first find out the value of the determinant and multiply by that constant 2, multiply by the constant 2, you will get the answer. So that means here, if any row or any column of a determinant is multiplied by a constant K, then the whole determinant is, the value of the determinant is multiplied by that constant K. So just find out the value of this determinant and multiply by that constant K, or multiply by constant for any row or any column and simplify, you will get the same answer. Now this is the example. One more example I will give for this. Let us consider one more example. Suppose if you remove any row or column, any element as a common factor from row or column, I will give one more example. Let us take example number 2. Now, the example number 2 is like this. Evaluate 102, 18, 36, 1, 3, 4, then 17, 3, 6. Now, here this can be written as, so this can be factorized as, you just keep 1, 3, 4 as it is, 17, 3, 6 as it is. This can be factorized. These are the factors of 6. So this can be written as 6 into 17. Again, this is 6 into 3. Again, 6 into 6. So here you can remove 6 as the common factor. 6, a constant, as 6 can be taken out. If you take 6 out, you are going to get 17, 3, 1, 6, 1, 3, 4, 17, 3 and 6. So this is equal to, so you know this property. According to the property, if 2 rows and 2 columns are same, this is same and this is same. First row and third row are same. Therefore, according to the property we have discussed in the previous classes, the value of a determinant is equal to 0. 6 into 0 is equal to 0. This is very important problem. So that means you can multiply by 6 or you can remove 6 as a common factor. This is what the property. Now coming to the next property. What is the property? Property number 5. This is very important property. If all the elements above or below the principal diagonal are zeros, if all the elements above or below the principal diagonal are zeros, then the value of a determinant is equal to the product of the principal diagonal elements. The product of principal diagonal elements. So here what is given? So the value of a determinant is equal to product of the principal diagonal elements if and only if all the elements above or below the principal diagonal are 0. So in this example, all the elements below the principal diagonal are 0. Now let us consider, let us derive this proof. Let us consider, let delta is equal to a1, a2, a3, 0, b1, b2, 0, 0, c3. Now all the elements below the principal diagonal are 0. According to the definition, according to the statement, if all the elements above the principal diagonal or below the principal diagonal are zeros, then the value of the determinant is equal to the product of the principal diagonal elements. Here, what is the product? So this is the product. So I can use this as the product. The value of determinant is equal to a1 into b2 into c3. This is the required answer. So all the elements below the principal diagonal are 0. Therefore, the value of this determinant is equal to product of principal diagonal elements a1, b1, a1, b2 into c3. Verify this. Let us prove this. Now let us prove this. a1 into, so this is plus, minus and plus. This element is gone. b2, c3 minus 0 minus a2 into, delete the row and column containing a2. This is gone. This is gone. 0 minus 0 plus b3, a3 into, yes, a3 into this is gone. This is gone. 0 minus 0. So a1 into b2, c3 remaining are 0. So this is equal to a1, b2 and c3. So a1, b2 and c3. So if all the elements below the principal diagonal are 0, then the value of determinant is product of principal diagonal elements. Similarly, if all the elements, say for example a1, 0, 0, b1, b2, 0, c1, c2, c3. If this is the case, here all the elements above the principal diagonal are zeros. So this is also equal to product of the principal diagonal a1, b2 and c3. Same answer you will get. So this is the property, very important property. Now let us take an example based on this property. So here the property is, if all the elements above or below the principal diagonal are zeros, then the value of a determinant is always equal to product of the principal diagonal elements. Now let us come to the example. Let us take an example. Let us take let A is equal to 2, 3, 4, 0, 1, 2, 0, 0 and 4. So according to the property, here all the elements below the principal diagonal are zeros. So therefore this is equal to 2 into 1 into 4. This is equal to 8. So if you want, you can verify this. See, expand plus, minus and plus. 2 into 1 fours are 4. So 2 into 1 fours are 4 minus 0. Minus 3 into this is gone. So 0 minus 0. Again plus 4 into, delete the row and column containing 4 is gone, 0 minus 1 into 0 is 0, 0 minus 0, this is 2 into 4, minus 3 into 0, plus 4 into 0, this is equal to 8. Otherwise, take one more problem. If determinant B is equal to determinant, so 4 minus 1, 5, 0, 3, 2, 0, 0, minus 1. So this is also equal to, so according to the definition, this is the value is below the principal diagonal are 0, 4 into 3 into minus 1, that's equal to minus 12. Or if I take one more example, all the elements above the principal diagonal are zeros, that is 3, 0, 0, 2, 4, 0, 1, 2, minus 1 or plus 1. Then this is also equal to, since all the elements above the principal diagonal are zeros, therefore this is 3 into 4 into minus 1, this is also equal to minus 2. This is how we are going to expand this. So that means if all the elements above or below the principal diagonal are zeros, then the value of a determinant is equal to the product of the principal diagonal elements. Very important property. This type of properties we are using to solve the problems in properties. Now let us come to the next property. Property number 6. What is this property number 6? If all the elements in a row or column are zeros, this is also important property. If all the elements in a row, any row or a column contains all the entries as zeros, then the value of a determinant is also equal to 0. If all the elements in a row or column are zeros, then the value of a determinant is also equal to 0. Now let consider let delta is equal to A1, A2, A3, B1, B2, B3, 0, 0, 0. Here, third row contains all the elements as 0. Then according to the definition, what is to prove here is to prove that the value of this determinant is equal to 0. Since all the entries in the third row are zeros, this is zeros, all the elements here are zeros, therefore the value of a determinant is equal to 0. Prove this. Let us simplify this. Plus, minus and plus. A1 into, this is gone, B2 into 0 is 0, minus 0 into B3 is 0, minus A2 into, this is gone, B1 into 0 is 0, minus 0 into B3 is equal to 0, plus A3 into, delete the row and column containing A3, this is gone, B1 into 0 is 0, 0 into B2 is also equal to 0 minus 0. So what is this? 0, 0 and 0 is equal to 0. That means, if all the elements in a row or column are zeros, then the value of a determinant is equal to 0. Now, let us take for example, let us take an example. Example, if determinant A is equal to, let us take this, 2, 3, 4, 1, 2, minus 1, 0, 0, 0. According to the definition, since all the elements in third column are zeros, therefore the value of this determinant is equal to 0. If you want, you can verify it. Plus, minus and plus. 2 into 0 is 0, minus into minus plus 0, minus 1 into this element, this row and column is deleted. 3 into 0 is 0, minus 4 into 0 is 0. 0 into any number is 0. This is 0 you are going to get. So if all the elements in any row or column are zeros, then the value of a determinant is 0. Let us consider one more example. So if I consider this example, let us consider if A is equal to determinant. So 2, 4, 5, 0, 0, 0, 3, 2, minus 1, then the value of determinant is equal to 0 because all the entries in second row are zeros. If you want, you can verify this. 2 into 0 minus 0 minus 4 into 0 minus 0 plus 5 into 0 minus 0, you will get 0. Even if it is a column, let us consider one more example. 2, 4, 1, 2, minus 1, 3, 0, 0, 0. Then here also we will get this as a 0. That means if all the elements in a row or column are zeros, then the value of a determinant is 0. This is also a very important property we are going to use to solve the problems in properties of determinants. Now, next, coming to the last property. What is the last property? Seventh property. If some or all the elements of a row or column of a determinant, if some or all the elements of any row or column of a determinant are expressed as the sum of two or more terms, then the determinant can be expressed as sum of two or more individual determinants. So, if some or all the elements, if some elements or all the elements of any row or column of a determinant are expressed as the sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. Let us consider, let delta is equal to a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3, b1, b2, b3, c1, c2, c3. So here first row contains the sum of two elements. In first row we have a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3. That means this first row contains sum of two elements. If some or all the elements of a row or column of a determinant are expressed as the sum of two or more terms, see, sum of two or more terms. So this is sum of two or more terms, sum of two terms. Then the determinant can be expressed as sum of two more determinants, sum of two or more determinants. So that means take all the first elements in the first row for the first determinant, a1, a2, a3, a1, a2, a3. Remaining row 2 and row 3 are same, b1, b2, b3, c1, c2, c3 as it is, plus second element, sum of the second element. Consider the second element in the first row, lambda 1, lambda 2, lambda 3, lambda 1, lambda 2, lambda 3, and b1, b2, b3, c1, c2, c3 as it is. So here a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3, this can be written as a1, a2, a3 plus lambda 1, lambda 2, lambda 3, and the remaining elements b1, b2, b3, c1, c2, c3 are as it is the same. Now let us expand this. Now let us prove this. Let us write this LHS. Now let me verify this. LHS I will take, expand this. So this is plus, minus and plus. a1 plus lambda into, multiply this, b2 c3 minus c2 b3 minus this element a2 plus lambda 2 into, multiply this, b1 c3 minus c1 b3 plus a3 plus lambda 3, a3 plus lambda 3 into, this is gone, b1 c2 minus c1 b2. Okay, listen, that is here a1 plus lambda, delete the row and column containing the b1 c2 minus c2 b3 minus a2 plus lambda into, this is gone, b1 c3 minus c1 b3 plus a3 plus lambda 3 into, this is gone, b1 c2 minus c1 and c1 and b2. Now expand this. So how to expand? Very simple. Let us take first a1 into this b2 c3 minus c2 b3. Okay, then again plus, minus into plus, it is minus, take this minus a2 into, take first all first elements a1, a2 and a3. So a1 into b2 c3 minus c2 b3. Now take this minus a2 into b1 c3 minus c1 b3, again plus a3 into b1 c2 minus c1 b2. On the other hand, let us take here, this is lambda 1 plus lambda 1 into same b2 c3 minus c2 b3 minus minus lambda 2 into same elements B1 C3 minus C1 B3 plus lambda 3 into B1 C2 minus C1 into B2. Now if you observe carefully, see, this is nothing but the expansion of, see, if I expand this, A1 into B2 C3, A1 into B2 C3 minus C2 B3. So if I expand this, what I will get? A1 into B2 C3, B2 C3 minus C2 into B3, first step. Similarly, if I expand this, what I will get? Lambda 1 into, lambda 1, this is gone, B2 C3 minus C2 B3. So lambda 1 into B2 C3 minus C2 B3. That means this is nothing but this is equal to the sum of two individual determinants. This is first and second determinant. So first determinant contains first element as A1, A2, A3, second element as B1, B2, B3, C1, C2 and C3. Whereas for the second part I am going to get lambda 1, lambda 2, lambda 3, lambda 1, lambda 2, lambda 3, B1, B2, B3, C1, C2 and C3. This is your RHS. That's it. So very easiest, very simple and very important property. That means if any row or any column contains the sum of two elements, then the determinant can be expressed as sum of two individual determinants, like A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3 can also be written as A1, A2, A3 first element plus lambda 1, lambda 2, lambda 3 as the first element for first matrix, first determinant and second determinant. Next, remaining two rows are same, B1, B2, B3, C1, C2, C3, B1, B2, B3, C1, C2, C3. Now expand. Let us expand this. If I expand, I will get the same LHS. A1 plus lambda into B2, C3 minus C2, B3 minus A2 plus lambda 2 into, this is gone, B1, C3 minus C1, B3 plus A3 plus lambda 3 into, delete this, B1, C2 minus, so simplify this. See, while simplification, you just take first elements, then second element. First take A1, B2, C3 minus C2, B3 minus A2, B1, C3, C1, B3 plus A2, A3 into B1, C2 minus C1, B2. Similarly, take lambda elements. This lambda 1 into B2, C3 minus C2, B3. Take lambda 2, then B2, C3 minus C1, B3. Again take lambda 3 plus lambda 3. So you will get, if you expand this carefully, let me expand this, A1 into B2 C3 minus C2. So the same thing you are going to get here in the first, next steps are same. If I expand, the first step I am going to get is lambda 1 into B2 C3 minus C2 B3. Same step I got. So therefore, this is nothing but the first determinant and this is nothing but the second determinant. So this is your required answer. This is very important property indeed. So these are all the properties, 7 properties in determinants. Now let us take one example for this. Let me take an example on properties of determinants. Let us discuss some problems based on these properties. These type of problems are very important. Usually you will get 4 more questions in part E. So in part E, there are 2 questions, question A and question B. This is for 6 marks and question B for 4 marks. So usually you will get this type of problems in part B. Very important. You will expect a question from this. Now let us take the first problem. What is the problem number 1? Prove that A, B, C, the first row, second row A plus 2x, B plus 2y, C plus 2z and x, y, z is equal to 0. Now what is to do here means just you should convert this in such a way that it should reduce us to the properties. Some 6 properties or 7 properties we have studied. Just convert all these in such a way that it should reduce us to a property, so that straight away you will get the answer without expansion at any stage. So here this type of problems can be solved without expansion at any stage using the properties, using the operations, elementary operations we have to solve. Now let us take LHS here. LHS, what is LHS? A plus 2x, x, B plus 2y, y, C, C plus 2Z and Z. This is given. Now, if you observe carefully using previous property number 7, if any row or column contains sum of 2 or more terms, then that can be expressed as the sum of 2 individual determinants. Here, this contains 2 terms, A plus 2x, B plus 2y, C plus 2z. So, this can be written as, take first element A, B, C and second element as A, B and C. Then it is X, Y, Z plus, similarly first row is same A, B, C. Second elements 2x, 2y, 2x, 2y and 2z. Third is X, Y, Z as it is. Followed? Very simple. So, here this contains sum of 2 terms. So, this can be expressed sum of 2 individual terms. A, B, C. First, take all the first term A, B and C, A, B, C. Third row is same X, Y, Z as it is. Again, first row for the second matrix, second determinant A, B, C. And second elements, all second elements 2x, 2y and 2z, X, Y and Z. Now, we have studied this. According to property, if 2 rows and 2 columns are same, so here first row and first column, first row and second row are same. So, this 2 rows are same. So, if 2 rows are same, then the value of a determinant is equal to 0 plus, here I can remove. So, according to property, any element is multiplied by a constant, then you can also remove the common factor as k. I can remove 2 as the common factor, k out. This is A, B, C. Again what I will get? X, Y, Z. Again here it is X, Y and Z. This is equal to 0 plus 2 into. Again according to the property, if 2 rows, 2 columns are same, X, Y, Z, these two are same. This is equal to 0. So 0 plus 2 into 0 is equal to 0 RHS. That's all. Very simple. This is 4 marks question. We'll get 4 marks very easily. So here, what is the problem given? That is A, B, C, X, A plus 2x, B plus 2y, C plus 2z, X, Y, Z. So you can split this. Take all the first elements in the first determinant, second elements for the second determinant. A, B, C, X, Y, Z. Again A, B, C first row, second row 2x, 2y, 2z and third row is as it is. So since 2 rows are same, the value of determinant is 0. We can remove 2 common factor. Then A, B, C, X, Y, Z, X, Y. Again 2 rows are same. Then the value of determinant is equal to 0. So that is equal to 0. The required answer RHS. Very important, simple problem. Now let us take one more problem. Let us take this problem. Prove that x plus y, y plus z, z plus x, y and z, x, y, 1, 1, 1 is equal to 0. So this is also a same type problem. Now without expanding, how can you solve this? Now let us convert this in such a way that, so to get it as 0, we should keep in mind that according to property, if 2 rows, 2 columns are 0, then the value of determinant is 0. Or if all the elements in a row or column are 0, then the value of a determinant is 0. Convert to those properties and simplify. That's all. Now let us take LHS. I will take LHS. X plus y, z 1, y plus z, x 1, z plus x, y and 1. This is LHS. Now convert this in such a way that if 2 rows or 2 columns are same. See here, x, y, if I add this, you will get x, y, z. Y, z, if I add this, you will get x, y, z. Z, x, y, if I add this, you will get x, y, z. So x, y, z, x, y, z, x, y, z, we can remove the common factor. Then we will get the answer. Very simple. So add these two. That means taking, this is very important, taking R1 dash or R2 dash is equal to R1 plus R2. Taking first row. So that is, just keep second and third row as it is. What is third row? Second row Z, X, Y, third row 1, 1, 1. Adding R1 plus R2. First element of row 1, first element of row 2. First element of this is row 1, this is row 2. Adding first element of row 1. x plus y plus z, x plus y plus z. So first element I will get x plus y plus z. Again second element, add these two, y plus z plus x. Put it in order, x plus y plus z, I will get x plus y plus z. Again adding these two elements, z plus x plus y, put it in order, x, y and z, you will get x plus y plus z. So see here in the first row, you can remove x plus y plus z as a common factor, 1, 1, 1, again z, x, y, 1, 1, 1. So this is x plus y plus z. According to the property, if two rows and two columns are same, see here, first row and third row are same, then this is equal to 0. 0 into any number is 0 or h. Just very simple. So simple problem it is. So here let us take LHS, x plus y, y plus z, z plus x, z, x, y, 1, 1, 1. Add these two, that's all. How to use the property R1 dash is equal to R1 plus R2. Don't get confused. We are adding first element of R1, first element of R2. Second element of R1, second element of R2. Third element of R1, third element, like that. So x plus y plus z, you will get x plus y plus z, y plus z plus x. And it seems you are adding like a column. No, we are adding first element of row 1, second element of row 1, third element, like that. X plus y plus z, y plus z plus x, z plus x plus y. So you will get x plus y plus z, x plus y plus z, x plus y plus z. We can remove x plus y plus z as a common factor. So 1, 1, 1, 1, 1, 1. Since these two rows are same, 1, 1, 1, 1, 1. First and third row are same. According to the property, then the value of a determinant is equal to 0. X plus y plus z into 0 is equal to 0. That is the simplest problem. Now, let us come to the next problem. This is the next problem. 1, 1, 1, A, B, C, B, C, C, A and A, B. This is very important problem for 4 marks. These are all very important problem for 4 marks. Let us take LHS. What is LHS? 1, 1, 1, A, B, C, B, C, C, A and A, B. Now, so you can use this taking, you can use these properties, taking R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R1. So that is, here this can be written as, first is say 1, A, B, C. First row is same. Subtract this, that's all. R2 dash is equal to R2 minus R1. This minus this. So here 1 minus 1, 0. B minus A. Again CA minus BC. That is finished. R2 minus R1. 1 minus 1. B minus A. CA minus BC. Next, R3 dash is equal to R3 minus R1. Subtract these two. That is 1 minus 1 is 0. C minus A. Then AB minus BC. Now see this, if this reduces to 0, straight away you can multiply all the elements below the principal diagonal are 0. Therefore this is equal to product of principal diagonal element. But let us convert this C minus A to 0 first. Now this is equal to 1, 0, 0. This is A as it is, B minus A as it is, C minus A as it is. This is BC. You can remove the common factor. You can remove C out, then A minus B. Here B is the common factor. It is A minus C. So I can remove the common factor. What is the common factor we are going to remove from this? So if you want, you can remove A minus B or B minus A. Let me take the common factor from here as A minus B. I will take, because the answer contains A minus B. So this is the common factor, A minus B. Then here I can remove A minus B and C minus A, because A minus B, C minus A and B minus C. Now if I remove the common factor, what I am going to get, this one changes, 1, 0, 0. Here A as it is. So B minus A can also be written as minus A plus B, or you can remove minus out. This is minus of A minus B. So B minus A is equal to minus of A minus B, therefore it reduces to minus 1. And This A minus B is gone. So here BC as it is. This is C. Again, in the last column, we are removing C minus A. This becomes 1. A minus C can also be written as minus C plus A, or I can remove minus out, then this becomes C minus A. So this becomes minus 1. Okay. So here, see, 1 A, B, C as it is, 0 we are removing A minus B, B minus A is removed out means then it becomes minus 1 because A B minus A is equal to minus of A minus B, and A minus B is gone. What is left over is C. Here we are removing C minus A as a common factor. 1 into A minus B can also, A minus C can also be written as minus of C minus A, minus 1 into B, it is minus B. To convert this to 0, add these two, that's all. Adding these two rows, it will convert to 0. That can be written as taking R3 dash is equal to R2 plus R3. So this is equal to, see here, 1 A, B, C same, 0, minus 1 C as it is. Add these two. So 0 plus 0, 0, minus 1 plus 1 is 0. Again, this is minus B plus C. Minus B plus C can also be written as C minus B. Yes, or B minus as it is. What is required to get is B minus, minus B plus C as it is, or C minus B, or I can keep C minus B. So since all the elements below the principal diagonal are zeros, therefore this is equal to 1 into minus 1 into C minus B. This is minus of C minus B can also be written as plus B minus C. So therefore this reduces to A minus B, C minus A into B minus C. So that means the answer is A minus B, B minus C and C minus A you are going to get as the RHS. So this is how we are going to solve. Listen, I will explain once again. So subtract these two. R2 dash is equal to R2 minus R1. 1 minus 1 is 0. B minus A, C A minus BC. Again, R3 dash is equal to R3 minus R1. This minus this. 1 minus 1, 0. C minus A and AB minus BC. So here CA minus BC, you can remove C as the common factor, A minus B. Here B is the common factor, A minus C. So I can remove A minus B and C minus A as the common factor. So A minus B into C minus A, this is 1, 0, 0. A into B minus A is taken out. If B minus A is taken, then this becomes minus of 1 and C minus A is 1. BC as it is, this is C into minus B. Now add these two. Adding R1, R3 dash is equal to R2 plus R3. This 1 A, B, C remains the same. The second row 0 minus 1 C is also same. 0 plus 0 is 0. 1 minus 1 plus 1 is equal to 0. Minus B plus C is equal to C minus B. Since all the elements below the principal diagonal are 0, therefore this is equal to product of principal diagonal elements. That is like this. I will write once again 1 into minus 1 into C minus B. Right. This is minus 1 into C minus B can also be written as minus of B minus C. So therefore minus into minus plus B minus C. So therefore the total answer is A minus B into B minus C into C minus A is the answer that we are going to get it as RHS. This is RHS. This is the problems. These are the problems, simple problems based on the properties of the determinants. Still we have so many problems. We will discuss that in the next class. So let us discuss that in the next class. Thank you very much for the day. We will meet again in the next class. Thank you.